Well, hello. So here we're going to go through practice test 2, Math 144. All right, so I printed off a copy of a practice test, but they always chop it off, and there's no way I know how to fix it. So I'll have to cam scan this. But anyway, just give you an idea of what that looks like. This first question here, it says, draw the angle in standard position. State the quadrant in which terminal side lies, or on the axis in which terminal side of the angle lies. So here it is. These are the choices. And so I put the choices. I just kind of drew the choices in there. All right. So let's see. Number one, we have -5 pi over 3. Now this is from chapter 6. Matter of fact, this right here is the ID 6.1.25. So that's the section number and the problem number in the exercises. So now 3 goes into 5 once, right? Once with 2 left over. So that means I'm going to go around in a negative direction. Now from here to here is 1 pi. Now I got to go 2/3 the way more over to the next pi, which is somewhere in here. If I'm going 2/3 of the way over, then that means this is in here is 1/3 or pi over 3. So this is my reference angle. Anyway, that's all they wanted. I'll take my glasses so I can see what I'm doing. Isn't that ridiculous? All right. So, and of course, it's in quadrant 1. And in this case, that looks a bit like F. This one right here. So, me now. That's quadrant 1. All right, number 2. Let's move on. It says, a right triangle with acute angle theta is given. Evaluate the 6 trig functions of the acute angle theta. Okay. So this is what it looks like. And it looks like this. Let me just take these off. Okay, so here's theta. We've got 9 here and a 7 there. All right, well, we just need to use the Pythagorean theorem to get that third side. Now we can't reduce it. 9 and 7 don't have any common factors, so we're just going to have to go and do it. 9 squared plus 7 squared is the hypotenuse squared. 81 plus 49 is the hypotenuse squared. And what is that? That's going to be 80 plus 50. 130, is that right? 130? And so now we get to do the square root. What is that? 13 times 10, which is 13 times 2 times 5. So you won't be able to reduce that at all. So that means then that h is the square root of 130. And now you can do your SOHCAHTOA on that. And just to remind you how that works, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And then you got cosecant, secant, and cotangent, and those are going to be the reciprocals. Okay, so that's going to be, HO, HAAO. Okay. So you can fill that in if you like. And what do we want? We want the sine of theta. We want the cosine of theta. Feel free to skip ahead. Tangent of theta. right? So opposite over hypotenuse. The hypotenuse now is root 130. So 7 over root 130. And then the adjacent is 9 over root 130. And then opposite over adjacent is 7 over 9. And then you can do the reciprocals. Cosecant of theta is going to be the reciprocal of sine. Root 130 over 7. Secant theta is the reciprocal of the cosine. So root 130 over 9. And then the cotangent of theta is the reciprocal of tangent, so 9 over 7. That's the easiest way I know how to do that. All right, but yeah, we couldn't reduce this because 130 is 13 times 10, and that's 2 times 5. So we don't have 2 of anything to bring it out. All right. So let's see, number 3, what do we got? Number 3. If theta is an acute angle of a right triangle and if secant theta is root 5, then find the other trig functions. Okay, number 3. Secant of theta is root 5. Okay, and you can think of that as root 5 over 1. Oh, what was secant? You know what I like to do? I like to put red boxes around stuff that I know I'm going to use again. Right. Or you can write it on your paper as soon as you sit down to your test. Right. Okay. So secant then is going to be hypotenuse over adjacent. And so my triangle is going to look like this. Hypotenuse is root 5. Adjacent is 1. So I'm going to do the Pythagorean again to get that other side. This is not a triangle that you recognize. See? So 1 squared plus, I'll call this y. Y squared equals the square root of 5 squared. Well, this is 5, right? 1 plus y squared is 5. And then you can subtract 1. Y squared is 4. And so y is 2. How's that? It's not going to be negative. All right, no negative distance here. All right. You know, and just stop me if I'm getting anything wrong. I gotta stop goofing off again. Okay. So now that we have all the sides here, we can get all the trig functions. I'll just list them out. Sine of theta, cosine theta, tangent theta, cosecant theta, secant theta, which we already know, and cotangent theta. So opposite over hypotenuse is going to be 2 over root 5. Adjacent, 1 over root 5. Opposite over adjacent, 2 over 1 is just 2. And then we can just do the reciprocals now. Root 5 over 2. Root 5 over 1, which is just root 5. And you know that's given. That should match what you have up here. And then the reciprocal of 2 is 1/2. There's that. So that's number 3. Okay, number 4. It says, determine the measure of the acute angle theta, for which tangent of theta is root 3. Okay, so we want theta. Okay. Well, you know, another thing I like to do when I sit down to my test is draw out my triangles. You know, you've got your pi over 4, that's 1 root 2. You know, you've got pi over 3. And that's, I like to do this one first because then the root 3, it goes right across. Then this is a 1 and that's a 2. And then you can do your pi over 6. And that's going to be the other way around. This is a 1 and a root 3 and a 2. Okay. So now if I think of this as root 3 over 1, and I know tangent is opposite over adjacent, well, which triangle is that? Opposite over adjacent, right? Well, that's going to be pi over 3. Opposite over adjacent is root 3. So theta is pi over 3. That one's so easy, it's hard. Okay, number 5. Should I box my answers? Does that help? Well, some of these are multi-part. So number 5 says use identities. Oh, I know everybody loves this one. We want to rewrite the following. Cotangent theta, sine squared theta, secant squared theta. Okay. And, you can think of this as over 1. These guys are all being multiplied, right? So now I like to write things in terms of sines and cosines. So sine, cosine, think sine and cosine. So cotangent, well, I know that tangent of theta is sine over cosine, right? So that means then that cotangent theta is the reciprocal, which is cosine theta over sine theta, see? So now what I'm going to do is I'm going to rewrite the cotangent like that. Cosine theta over sine theta. And then I've got sine squared is just sine times sine, right? So sine theta, you could even write it twice if you want, if that helps you. And, think of it as over 1, doesn't matter. It's in the numerator. And then secant is the reciprocal of cosine. So this would be like 1 over cosine times cosine, right? So what does that get us? Well, this is like in the numerator, right? And you could think of this as one big long fraction bar, right? And now you can see a sine cancels, right? And you can see that a cosine cancels. And you're left with sine over cosine, right? Oh, I know what that is. Tangent, right? Okay. Tangent of theta. There you have that. Move the page up. Yeah. So we got one sine to cancel, one cosine to cancel. You get sine over cosine, which is tangent. All right. Here's number 5. Number 6. What do we got for number 6? Find the angle of least non-negative measure theta sub c that is coterminal with theta is negative 29 pi over 4. Okay, so I got to say to myself, self, how many times does 4 go into 29? Well, 7 times 4 is 28, right? 7 times 4 is 28, and then there's 1 left over. 20, just double checking. And the negative just tells us which way we're going around the circle. Okay. And every time you go around, it's 2 pi. So here, let me just draw this. Going around this direction. And now I got 2, 4, 6. Now I got to go 7, right? So that's over to here, 7 pi. Now I got to go 1/4 of the way more. Well, from here to here is pi, so here to here is a half a pi. And then so a 1/4 is in the middle. So you're going to land over here somewhere, right? You're going to land in the middle there. And then, so now this angle in here, this is pi over 4 in here, right? But we want theta sub c. Theta sub c is the one that's in between. Yeah, actually, this should be an or equals. Where's my eraser? I don't have an eraser. This should be like or equals 0 to 2 pi. Okay, it's the one that's between 0 and 2 pi. So that's going to be from here to here. That is theta sub c. So what is that? Well, if this is pi over 4 in here, then this is going to be 3 pi over 4 over here. So theta sub c is 3 pi over 4. Okay. That was number 6. That also came from 6.1. Okay, number 7. I like these ones. Number 7. Find the, wait. The point -7, -4. Okay, -7, -4. Lies on the terminal side of angle theta. Find the 6 trig functions. Okay. You know, and you don't even have to draw the thing. Just know that this is x and this is y. And then you can use the Pythagorean to get the hypotenuse. And if you just leave the signs there, then those signs are built in. You don't even need to know, but it's in quadrant 3. Because you're negative on the x and you're negative on the y. That puts you in quadrant 3. So, but if this is it, theta here, you've got -7 on the x, you've got a -4 on the y. This is your triangle. And we've got -7 squared plus -4 squared is what? That's going to be our hypotenuse squared. 49, 16. What is that? That's 50 and 15, right? If you go like that. And that's 65, right? 65. Can we reduce 65? Well, 65. What is that? That's 5 times something. Well, 65. This is me doing chicken scratch. 65 divided by 5. 5 goes into 6 once, right? And then you got 15. So that means 13 times 5 is 65. So there is no reducing that, okay? So that means then that h is the square root of 65. Okay. And now we can do all our trig functions. Root 65. Sine theta, cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta. Okay. So opposite over hypotenuse, that's -4 over root 65. This one's -7 over root 65. And then opposite over adjacent, -4 over -7 is 4 over 7. And now we just want the reciprocals. Root 65, negative root 65 over 4. Negative root 65 over 7. And 7 over 4. All right. That's number 7. In the new page. Wait. Find the exact value of cosecant 11 pi over 3. Okay. So we got to do all that stuff there. Okay, so I'm going to start off with my 11 over 3, right? 3 goes into 11 how many times? No, 3, I guess 3 is 9, and then 2 left over, right? So I got 3 2/3. And it's positive, so I'm going positive direction. And now this is 2 pi, and then this is 3 pi, and then 2/3 of the way back over is going to land me here, somewhere here, right? And this in here, pi over 3. So this is my reference angle, is pi over 3. That just tells me what triangle I'm going to use. The other thing that I want to know is all students take calculus. This is another thing. All students take calculus. That tells me what is positive in which quadrant, and their reciprocals. So now, since we're here, this says that cosine and its reciprocal secant are positive in quadrant 4. So that means then that cosecant is negative in quadrant 4. So we're over here in quadrant 4. I think they asked that question too. What quadrant are you in? Okay, so cosecant is negative. Oops, cosecant is negative in quadrant 4 because of this. You could even verify those. If this is your little angle in here, cosecant is the reciprocal of secant, or I'm sorry, sine. So, what's the sine? And you can see that you're going to have a positive on the x and a negative on the y, and that's going to be opposite. So you've got a negative divided by a positive, and so that's going to get you negative for cosecant. All right. Now, what then? So we've got negative and we've got our pi over 3. So this is equivalent to a negative cosecant pi over 3. That's what we need to find. We need to find this. Well, I know that triangle. I've got pi over 3, root 3, 1, and 2. And cosecant is hypotenuse over opposite. And if you need, you can look at your other sheet for reference while you're working again. And where are we at? Okay. So cosecant is hypotenuse over opposite. I'm just double checking because it's so easy to get switched around in your brain on those. So it's a good idea to write those down and refer to them while you work. So now I've got negative, because cosecant's negative in quadrant 4, and the pi over 3 triangle, the hypotenuse is 2 and the opposite is root 3. So this is a negative 2 over root 3. All right. How's that? All right. Yeah, I don't have the answers. Number 9. Find the exact value. Okay, so this is a similar problem, only now we've got tangent of negative 9 pi over 4. So 4 goes into 9 twice with 1 left over. And we're going in a negative direction. So instead of going this way, I'm going to go that way. And there's 2 pi. And then we need 1/4 of a pi more. So that's going to put me here in the middle. Because remember, here to here is 1/2 a pi. I know, don't get confused on that. It's so easy to make that mistake. I've made that mistake. All right, so this is where we land, right here. So we're in quadrant 4. Quadrant 4 is where we land. And tangent is negative in quadrant 4 because all students take calculus. Right here. Tangent is positive in quadrants 1 and 3. Tangent is negative in quadrants 2 and 4. And our reference angle is pi over 4. This is pi over 4 in here. So that is our reference angle. So we are equivalent to a negative tangent pi over 4. Well, I know that triangle. That's going to get me a negative 1 over 1, right? Because it's opposite over adjacent. I almost said 1 over root 2. But it's opposite over adjacent, right? That's your 1, 1, root 2 triangle. Well, this is pi over 4, right? Should make that a little better. Okay. And so the answer is negative 1. Number 9. Number 10. I'm going to need a whole page for this one. Actually, let me just write this on here. Well, number 10. Number 10 has a lot of moving parts. Number 10 is y equals tangent of x. So, let me just start by drawing a picture for you really quick. And you should be able to just draw a quick sketch of this guy, just like sine and cosine. All right, so you can start like that. You could just go, with the asymptotes there. This is pi over 2. This is negative pi over 2. And we're coming up and making a wiggle like this. So this is your basic tangent graph, okay? And of course, things can happen up, down, left, right. But now for this one, they just want the basic properties, okay? So the first question is pick the graph. So right away, you know that C and D are out because they wiggle the wrong way. Let's see, A and B, it's got to be going through the origin. So it's going to be this one here. It says, is the function even? So A, is the function even? And the answer is no. It's actually odd. It's odd because it's symmetric about the origin. If it was even, then it would be symmetric about the y-axis. Part B, once you have the graph, you can pretty much look at the graph and answer these questions. Part B, it says, is the y-intercept equal to 1? And the answer is no, because it's going through the origin. Right there. This is the y-axis. Oh, okay. Part C. Is the range, okay, they try to screw you up on these. It says, is the range all real numbers except odd integer multiples of pi over 2? Okay, so you got to be careful with these. Sometimes they'll say domain, sometimes they'll say range. But you know what? The domain of this function is going to be everything except, pi over 2, multiples of pi over 2. It's going to go again, and then you got another pi. Anyway, but the range is going to be, they're asking about the range. The range goes down and then up forever. So it goes up and down forever in both directions, right? So it says, is the range all real numbers except odd integer multiples of pi over 2? So they're trying to get you confused with the domain and range. The answer is no. The range is negative infinity to infinity. Okay. Part D. Are the zeros of the form n pi, where n is an integer? Okay, zeros are x-intercepts, okay? In case you didn't notice, zeros are the same thing as x-intercepts. And so you can just look at the graph and see where it's crossing, and whenever they have an n, just try n equals 0, 1, 2. N is an integer. These are integers. Integers go in the negative direction as well. So then in this case, that would be 0, 1 pi, 2 pi, 3 pi, and so on. And so you can look at the graph and see, then you can answer the question. And so here's 0. Now I know that the period is pi, right? Period is pi, because from here to here is pi, right? So that means then from here to the next one is going to be pi. So the next one over here where it crosses again is going to be at pi, right? Because you got to add pi to get to the next point, right? So, and then again, another pi, and so on. And so, yes, those are zeros. So the answer is yes. And you can click on the little square with the arrow coming out of it, and that will make the graph bigger, or make the graph pop out, so you can see what you're doing. Okay, you can get a better look at those intercepts and whatever the graph is doing. Okay. Let's see, part E, what does E say? E says, is the interval for the graph on the principal cycle 0 pi? And the answer is no. The principal cycle is this one right here, negative pi over 2 to pi over 2. That's your principal cycle. Okay. I suppose I'll write that. Is the interval for the graph of the principal cycle 0 to pi? No, it's pi over 2, pi over 2, or I'm sorry, negative pi over 2 to pi over 2. Okay. That was that one. Some of these graph ones kind of take a while to do. Like I said, speed it up, slow it down, stop, skip ahead, whatever you like. Number 11. Number 11. Determine the amplitude and range. Y equals 1/2 sine x. And sketch the graph. Well, the amplitude is 1/2. That's it. And actually, that's the only change on the graph of sine x is, you know what sine x looks like? At least I hope you do. It looks something like this, right? And this is 2 pi out here. The period is 2 pi. That's where it starts repeating. And this is 0, this is pi. I'm just going to throw some stuff here. But instead of 1, the amplitude is 1/2. So that's what makes this one different. And this down here is negative 1/2. So that means your range is going to be negative 1/2 to 1/2. And yes, you're going to put brackets to include those endpoints because this point is a part of the graph. Okay. Well, let me just fill this in. This would be pi over 2. This is going to be 3 pi over 2 because it's 1.5 pi's. So there, you can get all your ordered pairs. They want the ordered pairs in here. You're supposed to fill in looks like the y values. You know, and just by looking at this, you can say it's going 0 to 1/2 to 0 to negative 1/2 and then back up to 0. And that's the order that you can put them in there. All right, but let's see what else they want. Oh, the range. They want the range. The range is negative 1/2, sorry, negative 1/2 to 1/2. And okay, so we've got 0, 0. You don't want commas, you just have them and then just type them in. And then we've got pi over 2, 1/2, and then we come back down to 0. So that's going to be pi 0. And then we're going to be down here 3 pi over 2. And then that's negative 1/2, and then back up to 0. So 2 pi 0. There. 0 pi over 2 pi, 3 pi over 2, 2 pi. 0, 1/2, 0, negative 1/2, 0. All right, I think that's all they want. And then, of course, they want you to pick the correct graph. On these guys, you know, you just got to make sure you can tell, you know, which way is it wiggling, you know, and a lot of times you're going to be looking at the period, you're going to be looking at the amplitude, and whether or not it might help to know whether or not it's going through the origin, you know, pick a point there. What are those x-intercepts? And what's the amplitude? And that's going to help you decide which graph. Number 12. Okay, so now we have y equals negative 3 sine of negative 5x. Okay, so first off, when you're looking at, you know, y equals a sine bx, right? When you're looking at that, b is greater than 0. So that means you got to get rid of this. You got to make that positive. Okay. So how do you do that? You know that sine is odd. So what does that mean? That means that sine of negative x is negative sine x, right? And you can verify that a couple of different ways. You know it's odd because it's symmetric about the origin. Also, you might recall that f of negative x is negative f of x when it's odd. Okay, you might remember that from 143, or if you're doing 143, then you'll see that. But odd functions, you can take that negative out and put it in front. Okay. Let's see, what else do I want to say about that? Nothing. Just that this negative is going to come out here, and then you're going to have a -3 times that negative, which is going to change the sign. So it becomes -3 times a negative sine 5x. So I'm trying to spell it out a little bit better so you can see what's happening with the negative. And that's just going to be a +3 sine of 5x. You know, once you get the hang of that, you're going to look at that and go, oh, 3 sine 5x. Yep. And this is what we want to graph. Okay, we don't want to try to figure out what this graph looks like with that negative there. So, but now I know I have a positive sign going on. You know, it just is doing, oh, the other thing is the period now is a 2 pi right over b. 2 pi over b. And in this case, b is 5, so 2 pi over 5. So I know I got a positive sign, so I'm going to wiggle like this, okay? And if my period is 2 pi over 5, that means this over here is 2 pi over 5. And now if you want to get these other points that are supposed to be evenly spaced, then you can multiply this by a fourth to get all of those. And, you know, sometimes you'll see me write increments. Okay, we're going to go 2 pi over 5 times a fourth. And, you know, you can reduce the 2/4 to 1/2. So you're going to get pi over 10. If you want to go 2 pi over 20 and then reduce that, it's pi over 10. So that means each of these is worth pi over 10. So you're starting at 0 here, and this is pi over 10 here. Right? And if you want to write it out neatly like this, 0, you've got pi over 10. And if you want, you can go 2 pi over 10, right? 3 pi over 10, just so you can see the pattern. 4 pi over 10. 5 pi over 10, right? Oh, we don't need that. That's too much. So 1, 2, 3, 4, 5. There should only be 5 points. But there, see, once you reach that last one, then you know that's when you're supposed to stop. And so I'm just going to rewrite that. Pi over 10. This is pi over 5. 3 pi over 10 doesn't reduce. 4 pi over 10 is 2 pi over 5. And that should match what you have over here. So now these are the x coordinates on here of your ordered pairs. So if you want to fill it in, pi over 5, 3 pi over 10. Okay. So those are my x coordinates. Now, if you're looking for your y coordinates, the amplitude is 3. So that means that this is 3 here, and this down here is -3. So that's how you can get all your ordered pairs now. So at 0, you're at 0. At pi over 10, you're at 3. At pi over 5, you're at 0. And then at 3 pi over 10, we're at -3. And then at 2 pi over 5, we're back up to 0. So those are your quarter points. Did we answer all the questions? Amplitude, the range. Okay, so your range is going to be -3 to 3 with the brackets. And I also want to point out that A can be negative. That only tells you which way it goes. You know, if it's negative, it's going to reflect on the x-axis. But amplitude is always positive. Okay. It's just the negative just says which way it wiggles. Okay. What else? Okay. Number 12. Amplitude, range, period, quarter points, and graph. So we've answered all the questions. The period is 2 pi over b. And these are your quarter points and the range. And there's your graph. When you're picking your graph, make sure you're wiggling the right way. Make sure you're going through, the origin. If you are, you can check that point. Make sure that your period is correct and that your amplitude is correct. Okay, all of these have the correct amplitude. But right away you can see that, oh, that's weird. That's just weird. That one actually has a shift. Not sure what that is, but it's wiggling this way. So you know it's not this one. And so it could be this one or this one, but see, notice your period here. So this one is not right. 10 pi is not your period. Okay. All right, so what's next? Number 13. We got another graph. $14 is another graph. Okay. Oh, 15 is another graph. Okay. It's all right. So this one, we've got y equals cosine of x plus 3 pi. So there's only one thing that's happening right here, and that's the 3 pi. So this is a shift. So if you think of a cosine of bx minus c, then you can see that this is minus a negative 3 pi. This helps you determine what the shift is. Okay, cosine of this thing. And there's a 1 in front. Okay, so your amplitude is 1. Did they ask for that? They do. Okay, so your amplitude equals 1. Remember, that's never negative. And what else do they want? The range. Well, there is no up or down shifting, and the amplitude is 1, so that means the range is still going to be negative 1 to 1 on your normal cosine graph. What does the cosine graph look like? The cosine graph, a positive cosine looks like this. Just a quick sketch. It looks something like that. And what's happening is this is going to get us a left shift, right? We're going to shift the graph to the left by 3 pi. So we're shifting left by 3 pi. That's what we're doing. So, really what that means then is all you got to do is you take your quarter points here on the cosine and subtract 3 pi from all of them, from all the x's. That's all you got to do. All right. So I know what this looks like. This is 2 pi here. This is pi 0. Okay. So we've got 0. And we've got pi over 2. This should be familiar. Pi over 2. And then we've got pi. And then we have 3 pi over 2. And then we have 2 pi. Right? Now, if we're going to shift left by 3, I'm going to subtract 3 pi. 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 And I joke around and I say, when you get done with this class, you're going to be really good with fractions. Okay, well, 0 minus 3 pi. I think you can handle that. That's a negative 3 pi. All right. Now this one here, you're going to have to get a common denominator. You could write the 3 as a 6 over 2, right? Instead. So what is 1 minus 6? That's a negative 5, right? Negative 5 pi over 2. Okay. Now what's 1 minus 3? Well, that's a negative 2. Right. And then we can do the same thing here, make the 3 into a 6 halves, right? And so 3 minus 6 is a negative 3 halves pi. And then 2 minus 3, that's a negative 1 pi. Okay. So those are my new x coordinates after I shift left by 3 pi. Your y coordinates are not going to change. So if you just look at the graph here, you can see you're up here at 1. Just remind yourself that this is 1. Okay, so we got 1. Then it comes down to 0. Then it comes down to negative 1. Then it comes up to 0. And then it goes back up to 1. And there you are. There are your quarter points. Did we answer all the questions? Well, you're going to have to pick the graph. So if you're going to pick the graph, you might want to use this one right here. This one might be good to spot. Pick that graph. So what do we got here? It's hard for me to tell on this little tiny graph. Negative pi 1. Okay, so which one of these has negative pi 1? Well, let's see. 1, 2, 3. So these are all going by pi, right? So there's 0. So this is negative pi 0 is on this graph. So that one's out. This one has negative pi negative 1. So that one's out. We want negative pi positive 1. This one is not it either. This one's negative pi 0. This one is negative pi. I know this is terrible, but negative pi 1. I know this is terrible, but this is the graph right here. I had to sketch it in. But anyway, it should look like, it should have this on there. And you can click those things to pop them out. And, you know, use 1 or 2 points and process of elimination. You should be able to get it down to the correct graph. No, that was 13. And that was the only one that had this point on it. Okay, the next one is number 14. We've got something similar, but with more moving parts. Maybe I should start a new page. 14. Yeah, let's start a new page. I just don't want to run out of room. It's y equals 3 cosine 6x plus pi plus 1. Okay. So what I'm going to do first, well, I can see my amplitude is going to be 3, right? So right away, you know your amplitude is 3. And I also know that it's going to shift up 1. I usually like to do the range last, but yeah, that's probably best. Okay, I don't want to mess with that yet. I'm going to take care of my x's first, and then I'll figure out the y's. That's just the way I like to do it. Okay, all the basic questions. So what I want to do is I'm noticing that this is a positive cosine, right? So that means it's going to look something like this. So that's my basic shape initially. And my period is 2 pi over b. And that reduces to pi over 3. So that means this point out here is pi over 3. This is before any shifting, okay? So we got to figure out where these points are first. We got to figure out, well, you know, how big is the period before we can do any shifting. All right. So that's why we have to do this part first. And now I need my increments. I'm going to multiply the pi over 3 times a 4. And that'll get me pi over 12. So that means each of these are worth pi over 12, right? And so, oh, yeah. All right. So initially, though, my cosine, I've got my pause this. Nothing. It's never anything. Well, that's not true. Okay, so we start at 0, right? And I know that the first one is going to be pi over 12, right? So here to here is pi over 12. And then you could say 2 pi over 12, 3 pi over 12, 4 pi over 12. See how that works? So I'll just write it. 2 pi over 12, 3 pi over 12, 4 pi over 12, which reduces to pi over 3. So this is the last one. So now what? Okay, now we know our phase shift, right? Phase shift is going to be C over B. And what is C? C is going to be a negative pi. Remember, this is like minus negative. Okay, so C is negative pi. So negative pi, and then B is 6. So that means we're going to shift to the left because it's negative. This is a left shift by pi over 6. So that means we have to subtract pi over 6 from all of these. So minus pi over 6, I'm just going to leave those. Minus pi over 6, minus pi over 6, minus pi over 6, minus pi over 6, minus pi over 6. All right, so we're going to need common denominators. I can put 2 over 2 just to simplify this mess. 2 over 2, 2 over 2, 2 over 2. Just makes the calculation a little easier, right? Okay, so 0 minus pi over 6 is going to be a negative pi over 6. Okay, that one's easy. And then here we've got a 1 pi over 12 minus 2 pi over 12. 1 minus 2 is a negative 1. Okay, so that's a negative pi over 12. And now what do we got? 2 pi minus 2 pi is 0. Okay. Yeah, pi over 6 minus pi over 6 is 0. Okay. And then here, what do we got? 3 pi over 12 minus 2 pi over 12 is pi over 12. And then what do we got? 4 minus 2 is 2. So 2 pi over 12, which reduces to pi over 6. Okay, so these are my x coordinates now after we've shifted. So, you know, we've shrunk it down to pi over 3, and then we shifted it to the left. And these are my new x's. Okay, I'm just going to write them down here. Negative pi over 6 negative pi over 12, 0, pi over 12, and pi over 6. And you can readily see that from here to here is going to be, pi over 12. It's pi over 12 from here to here to here to here to here to here to here. Okay. So, and because those were our increments up here. So that should kind of mesh with what we got up here, that these are all that big. From here to here is pi over 12. From here to here is pi over 12. Here to here, pi over 12, and so on. Okay, so that should mesh. So those are our x values. And now what we're going to do is we're going to figure out what the y values are. All right. Okay. Now, we started here at 3. So this was 3, right? So I'm just going to write down what they were initially. Initially, it's 1, 0, negative 1, 0, 1. Initially, right? For the basic cosine graph. Then the amplitude is a multiplier. You're going to multiply all of these times 3. Okay. Notice that doesn't change on the 0, right? That this becomes 3, 0, negative 3, 0, and 3. See how that works? But now, since our d, this is plus d, right? This is y equals a, oops, a cosine bx minus c plus d. And d gives us the up or down shift. Now we got a plus 1, so that means we're going to shift the whole graph up 1 unit. So I got to add 1 to all my y values. Okay. So at the end of the day, what do we get? We get negative pi over 6. And then this is going to be 3 plus 1 is 4. And then we have 0 plus 1 is 1. So negative pi over 12, 1. And then here we've got 0. We've got negative 3 plus 1, negative 2. And here we have 0 plus 1. So pi over 12, 1. And then pi over 6, we got 4. And that should mesh, that the amplitude is going to be 3. So here to here, you can see is 3. So 1 becomes your new base, right? When you're shifting. And notice that you've got this low point here. So this is going to help you with your range. You've got negative 2 to 4 is your range. It's easier to see now that you're going negative 2 to 4 after you've shifted it up 1 unit. And you're going to pick the graph that does cross down into the negative. So this is what I'm talking about. Here are your choices, right? These are your choices. This is not shifted up. This is shifted down. This is shift down. So that's not it, right? This is completely above the x-axis. So that's not it because there are no negative y values. This one is down a little bit. This one looks right. This one here is not shifted up or down at all. So C is the answer. And you can, like I said, you can click on this guy with the arrow thing to get a better look. But it's the only one that dips down a little bit below the y-axis. I think I've answered all the questions. We got amplitude, range, period, phase shift, and quarter points. Period, amplitude, range. Phase shift is negative pi over 6. And those are your points. Right there. Okay. Oh, hey, look, the sun's coming out. Number 15. So now, oh, this one's pretty straightforward. Y equals tangent x plus pi over 4. All right. So all this is the tangent function shifted to the left by pi over 4. That's it. You know, and they're going to ask the principal cycle. They're probably going to ask that. Didn't we do one like this earlier? I thought we did. Well, no matter. So first thing I want to do, I mean, you know what the tangent looks like. It looks something like this. This is pi over 2, and this is negative pi over 2, and it's doing this. Okay, there's your tangent. And so this is pi over, negative pi over 4, negative 1. And this is pi over 4, 1. Okay. So these are your, so we don't have quarter points, we have halfway points. Okay, but first they're going to want to know the principal cycle, I'm sure. Yeah. So what you're going to do is you're going to take this x plus pi over 4, and you know that that's going to be in between negative pi over 2 to pi over 2. This is going to get you the principal cycle of this function. So here we do negative pi over 4, negative pi over 4, negative pi over 4. We're basically solving a 3-part inequality. Okay, and I'm going to have to do a 2 over 2 on this one, right? So negative 2 pi minus pi is going to be a negative 3 pi, right? Negative 3 pi over 4. And then here, again, I got 2 over 2. So 2 pi minus a 1 pi is going to be pi. So that's pi over 4. So these are the new asymptotes, the new vertical asymptotes that we have when we shift it to the left by pi over 4. Okay. So the vertical asymptotes then, the left one is going to be x equals negative 3 pi over 4. Remember, these are vertical lines, so you have to have x equals. Okay, this is the left, and then x equals pi over 4 is the one on the right. Okay, so this is the left vertical asymptote and the right vertical asymptote. Oh, and they're going to ask for the principal cycle. And you're going to use parentheses because these are asymptotes. You can't include asymptotes. It's just negative 3 pi over 4 to pi over 4. That's it right there. So now what do they want? The period has not changed. If there was something here, that b is 1 here, but the period is going to be pi over b. Okay, and b is 1. Period is pi over b. B is 1, so that means the period is pi. Okay. And what else do they want? Left vertical asymptote, right vertical asymptote. and then the center, and then the halfway points. Okay. So the center then, well, guess what? We shifted the whole thing to the left by pi over 4, so the center is going to be negative pi over 4, 0. Okay. Now, if that didn't work out for you, if you somehow got kind of mixed up, you can also find the center by adding the asymptotes. Here, let me do it this way. Asymptotes and divide by 2. Right? This is basically finding the average. So, if you want to see how that works, you can say, well, that's, this is just a, for instance, you would say negative 3 pi over 4 plus pi over 4. And now, since you're dividing by 2, that's the same thing as multiply by half. So what is that? That's negative 3 plus 1 is a negative 2. Negative 2 pi over 4, and then times a half is going to be negative pi over 4. Ta-da! Okay, same thing. So you can find it that way. As a matter of fact, this is the exact way that we're going to find the halfway points. So halfway points. Because what you're doing is you're finding the point that's halfway between, where the 0 is and where the asymptote is. So you know that your function looks something like this now. I know my graph sucks, but this point here is negative pi over 4, right? And you've got an asymptote here and an asymptote here. This one happens to be pi over 4 here and negative 3 pi over 4 here. So basically you're finding out, what's in between, what's halfway between here and here. And then we've got negative 1 here, right? And then this one will get us between here and here is going to get us the right halfway point. And that y coordinate is going to be 1 in this case. So let's see, what do we got? Negative 3 pi over 4. So this is the left one. Negative 3 pi over 4 plus a negative pi over 4, right? And then times a half. So that's a negative 4 pi over 4, which is negative pi, times a half is negative pi over 2. All right, so this is negative pi over 2 here. So negative pi over 2, and then negative 1 is the y coordinate. So that's your left halfway point. Your right halfway point, you got to do your center again, which is negative pi over 4, and then you're going to add the one on the right, which is pi over 4. Oh, look at that. And that's 0. So my graph is a little bit off. It's 0. This is right here. So it's coming up like this. It's going through the 0. So 0 is halfway between pi over 4 and negative pi over 4. I should have noticed that. But there it is. So this ordered pair then is 0, 1. That's your right halfway point. Okay. And then you can pick the graph. You know it's your basic tangent shifted to the left by pi over 4. And you're going to have to zoom in. This one doesn't have the right amplitude, if you will. A. It doesn't have the right A. Neither does this one. And this one is wiggling the wrong way. You know, it's got to wiggle this direction, and it's got to go through 1, not a half. They shrunk it down. I don't know. So there, number 15 did take that whole page. Number 16. Okay. Number 16 says, find the exact value of the following expression. You got inverse tan of -1. I mean, that looks kind of scary, doesn't it? What? Well, I tell you what, you know, we've got an inverse function right here. So, you know, let's just call it you know, theta. We could call it theta. Now, because it's the inverse, that means that I can trade the x into y. So that means that tangent of theta equals -1. See what I did there? I just traded the x into y and took away the notation for the inverse function. So where's the tangent of theta equal to -1? Oh, well, let's see. -1/1. Let's do it that way, right? Is that a triangle? Oh, look. Is this going to work? Theta. Opposite is -1 and adjacent is 1. Oh, that looks like pi/4, right? You know, and you can use Pythagorean theorem to double check that. Theta is going to be pi/4. But now not so fast. Tangent is negative. So tangent is negative, right? So you got to be a little careful here. All students take calculus, right? All students take calculus. Tangent is positive in quadrant 1. Tangent is negative in quadrant 4. Inverse tan, the principal cycle of the inverse tan, it goes, so let me just remind you, we've got -pi/2 and pi/2, right? This is what tangent looks like. And when you switch it, you know, the domain and the range get swapped. But because of the nature of the inverse function, we can only operate in, it's only defined in quadrants 1 and 4. The inverse tangent is only defined in quadrants 1 and 4. We have to have a restricted domain. So we have a restricted domain, and that's because our function has to be 1-to-1, right? So we restrict a domain here, because then when we trade the x and the y, we need that to be a function as well. So that means that we can only operate in quadrants 1 and 4. Now tangent is positive in quadrant 1 and negative in quadrant 4. And since this is negative here, that means that we have to be in quadrant 4. So quadrant 4, so if I'm looking at it this way, then tangent is only, you can only operate in these 2 quadrants. So that means you have to be here. If you want pi/4, you have to be at -pi/4. Because theta has to be in between -pi/2 and pi/2. So that's this. In order for that to exist, well, this has to be, we have to have the restricted domain. So theta has to be between negative pi over 2 and pi over 2. And the only way we can get that with pi over 4 is negative pi over 4 this way. So theta is negative pi over 4. That's how we get that negative in there. All right. I know, that's a weird one. Oh, okay. Okay. Okay, so we've got cosine of the inverse cosine. See, now this is where I wish I had my pretty pictures with me. Negative 1 over root 2. Now you have to say to yourself, self, is this in the domain of the inverse cosine? And I might have that. I just have to have a sticky here. Yes, yes. Okay, so we're talking about cosine. Let me see. Well, my pictures aren't all that pretty. I don't know if that'll be helpful. So if I have the cosine, right, you know what the cosine looks like? It looks like and then it starts to go up, right? But you need to restrict that domain in order for it to be a one-to-one function. If it's not a one-to-one function, then the inverse doesn't exist, right? So I can only go from 0 to pi, right? So you say, okay, so 0 to pi. This is your cosine, right? Y equals cosine x. So x is between 0 and pi, and that's going to be your domain. Just say domain. The domain here is 0 to pi, right? And also the range is going to be from negative 1 to 1. I think I'm running red. Negative 1 to 1 is the range. So when I get the inverse function, the domain and the range is going to switch, right? So here, this is pi negative 1, right? And this is 0, 1. So when you draw a picture of the inverse, it's going to look really weird. But you're going to trade this. You're going to be going through 1, 0, and you're going to be going through negative 1 pi. And you want to say to yourself, is this in the domain of the inverse function? Let me get a picture. Let me draw it. So I drew the inverse function on my page here. It looks something like this, okay? And you want to say to yourself, self is negative 1 over root 2 in the domain of this function, right? Your domain and your range are traded. So you want to say, is negative 1 over root 2 in the domain of this inner function? You're always looking at the inner function when you're answering this question. So basically, negative 1 over root 2, is it in between, is it in this domain? The domain is going to be the range of this function, so negative 1 to 1, basically. Is it in there? Is this in there? You know, and I'm thinking it is. And what is 1 over root 2? What is 1 over root 2? You know, you say, well, is it bigger than 1? Well, 1 would be root 2 over root 2. What is root 2? Root 2 is, root 4 would be 2, root 3, root 2, root 1. You know what? So you say this, which one's bigger? Is this true? Is this more negative than that? I think so. Yeah, I think that's in there. I can double check on my calculator, but I'm pretty sure. I feel really silly. Don't fault me for that. This is late. This has been going on for a while. And I'm having eyeglass issues. This is 1.4. So root 2 is about 1.4, and I should have known that. Feeling silly. So, yeah, so if this is negative 1.4, then that's in there. Okay, and the answer is yes. Okay, so what that means is that you can use the cancellation equations. So use the cancellation equation. And that means you could just pop that guy right out. So these are the cancellation equations. Let me just show you what they are. So it's sort of like, you know, if this is in here, if this is in the domain of this function, and these two are inverse functions of each other, then this comes right back out. Okay, this becomes the x. We just bring it right out. And same here. These two are inverse functions of each other. If this is in the domain of this function, then you can just pop that right out. Okay? And it's just that same way through the whole thing. But you're always looking at the domain of the inner function. If it's in there and these are inverse functions, then you just bring that guy right out. Okay? So that means then the inverse cosine of negative 1 over root 2 is negative 1 over root 2, because this is in the domain of that. That's what I've been trying to say. All right. You know, usually that goes a lot faster when you're not explaining it and you just know it. Okay. What number is that? 17. So we can move on to number 18. Okay, 18. What do we got? Find the exact value. Inverse sine of negative 11 pi over 2. Okay. So you want to say to yourself, what is the domain of the inner function? Restricted. What is the restricted domain of the inner function? Okay. So that's the sine, right? What does sine look like? Sine looks like this, right? But, you know, so you're coming on up, but then it starts to go down, so you can't do that. So you have to take this piece here, and that's as good as you can get. So it comes up like this, and it goes to there, and this is pi over 2, right? What do you want? Pi over 2, negative pi over 2, right? And these endpoints are included. So the domain is going to be negative pi over 2 to pi over 2. That is the restricted domain of the inner function. Now, so you say to yourself, self is 11 pi over 2, and you're going to get good at this. Negative 11 pi over 2, is that in between negative pi over 2 to pi over 2? And the answer is no. Right? What is 11 halves, right? 11 over 2. 11 over 2, 2 goes into 11, so we got 5 with 1 left over, right? Okay. So it's totally not in there. So what we want to do is we want to evaluate the inner function. So we are going to evaluate sine of negative 11 pi over 2, right? So I'm going to go around just like we were doing before. Negative direction, right? We're going in the negative direction, and we're going to go 5.5 pi. So we've got 2 pi. Oh, you can't see. 2 pi. And then we got 4 pi. And then we got 5 pi. And then we got a half a pi. Well, that lands us right here. That's a half a pi, right? So, well, what is that? Well, let's see. That's a 0 on the X, and let's say a 1 on the Y on the unit circle, right? So this would be equivalent. Sine is going to be, now if you remember the other triangle that says on the unit circle, X and Y and 1, right? If you remember that, then the sine is going to be opposite over hypotenuse. So that means the Y coordinate is the sine. So when you're looking at the ordered pairs on a unit circle, the first one is actually adjacent over hypotenuse is the cosine, right? And then this is the sine. So the sine is the Y value, which is 1. That's it, it's 1. So this equals 1. Because this is the sine of 90 degrees or pi over 2 or whatever you like. The sine of t is 1. Okay, so that means that we now have inverse sine of 1, right? We're just going to replace this. This is now equal to 1. This piece now equals 1. So now it's inverse sine of 1 is what we got to do. And let's just call it theta. And that means the sine of theta is 1. Well, guess what? That's pi over 2. That's just terribly easy, isn't it? All right. I should probably check my answers before I post this video. There's a lot of moving parts to this, you know? All right, number 19. Oh, this one. We've got the cosine of the inverse sine of 9u. Okay. All right. All right, well, I want to know what this is, right? I want to know what that is. I'm going to call it theta, right? So if inverse sine of 9u is theta, then that means the sine of theta is 9u. And now what you can do is a triangle. You can go 9u over 1. Right, so here's my triangle. Let's call this theta. Opposite is 9u. The hypotenuse is 1. Opposite over hypotenuse. And now if I want to get the x, let's just call this x here. I can do x squared plus a 9u quantity squared equals 1 squared. And I'm going to try to solve this thing for the x. And this is going to be 81u squared equals 1. And I can subtract that over. 1 minus 81u squared. So that means I have the square root of 1 minus 81u squared. And don't try to do anything else with it. Because, you know, if I have two things multiplied together underneath here, then it comes out. But they have to be identical. You know, you're looking at this and you're thinking, well, I'm not sure what you're thinking, but it's actually a difference of squares. I just want to point this out. This is 1 minus 9u times 1 plus 9u. These are not the same. Okay, so don't try to simplify that, okay? So I don't have the same thing that I can pop out or anything. So don't try to simplify that radical, because I know students try to do it, but don't do it. Okay. So my triangle now becomes this. I've got the square root of 1 minus 81u squared, and I have 9u here, and I have a 1 there. So now you can do anything, any trig function they're asking for, but we want the cosine of theta. And now that we've figured out theta, we want cosine of theta, and that's going to be adjacent over hypotenuse. So that's the square root of 1 minus 81u squared divided by 1, which is just 1 minus 81u squared. Okay, that was 19. Boy, this is going to be a long video. I'm sorry. Number 20. Oh, this one. Okay, so they want y equals secant x. So I got to tell you, you know, the secant is the reciprocal of cosine, right? Reciprocal of cosine. So what that means is wherever the cosine is 0, the secant is going to be undefined. So what we want to do is we want to draw y equals cosine of x. Cosine of x looks like this. And then it's going to keep going. I don't know, whatever. Something like that. Now the secant x, I'm going to mark this in red. Wherever cosine is x, or I'm sorry, wherever cosine is 0, the secant x has an asymptote because it's undefined. Divide by 0. So I'm going to put asymptotes where it's crossing the x-axis. Like that. And, you know, further investigation is going to tell you that wherever there's a max on the cosine, that's going to be a min on the secant. And going the other direction like that. So you just draw this out and then just fill it in like this, and then you have your graph. That's it. You know, and then you can answer the questions and so on. So it says, is it an even function? Yes. So A, yes, it's even. And you know that because cosine is even. I should be proper. Because cosine of x is even. Also note that it's symmetric about the y-axis. Okay. Does the function obtain a max at x equals pi n? It could also say n pi, whatever, where n is an odd integer. So you're going to have to look at the graph for that. Also, if n is an odd integer, then that means that n is 1, 3, 5. So look at the graph and see, do we have a max at pi, 3 pi, 5 pi, and so on. So even just the first one, you should look and see. So well, here's the cosine, right? The cosine has a max at 0. It's got a max. So it's going to have, secant is going to have a max where the cosine has the min. So what's this point right here? Right? Well, I know that. This is 2 pi here, and this is pi. So this is 3 pi over 2. And so I'm going to say no, because this is 3 pi over 2. It's not pi or 3 pi or 5 pi. So the answer is nope. Max at, that's 3 pi over 2. Right there is 3 pi over 2. Because this is 2 pi right here. Oh, wait. I'm sorry. My mistake. This is 2 pi. See, but you're going to have the graph. You can pop those out and look at that. This is pi. Oh, the answer is yes. I'm so sorry. It only shows I'm human. I read my graph wrong. But you're going to have the correct graph, and you're going to pop that out, and you're going to look at it. And then you'll be able to answer the question correctly. This is 2 pi. Here's cosine. Right? That's 2 pi. This is pi. I just read my graph wrong. So, and yes, the secant has a max at pi, and then at 3 pi, 5 pi. So yes. Let's keep going. Part C. Is the range negative infinity to infinity? And the answer is no. That one's easy because there's a gap between, like -1 to 1. It goes down forever, but then it stops. There isn't any secant graph in between 1 and -1, right? So there's a gap there. So the range is actually negative infinity to -1, union 1 to infinity. Okay. Part D. Are the equations of the vertical asymptotes of the form x equals n pi, where n is an integer? So that's going to be, 0, 1 pi, 2 pi, 3 pi, etc. And what do we got? Well, so now that I've labeled my graph correctly, this is pi over 2. So the vertical asymptotes at pi over 2, not pi. We already, yeah. So the answer is no, just looking at the graph. pi over 2, etc. Okay. Is there an E? Does the function have a period of 2 pi? Yes. So period 2 pi. Yes. So you've got, it's so easy to look at this and go, oh, well, it's just pi. But then it's this and then this, and then it starts to repeat. So you have to include both of these pieces. So, from here to here, then it starts to repeat. So the period is 2 pi. Okay, well, that was the last question. I hope I didn't bore you to tears. I know it was a little long, but it is what it is. Oh, I know, you hate that expression, right? Okay, I will try to post this as soon as I can. Bye.